All right, guys and gals, let's do some pH calculations. Psst, drop the bass.
Okay, let's see the calculations.
Okay, so what we're going to do is we're going to write out all the formulas that we're possibly going to use in our logarithmic function. So you're going to be using the log button on your calculators. If you don't know what a logarithm is, that's okay. Just know where the button is on the calculator. So
Remember that it's a log scale, so
pH is equal to the negative log of the hydrogen ion concentration. That negative is really important, the negative log. All right, POH is equal to the negative log of, what do you think?
the hydroxide ion concentration.
All right. All right. What other things do we need to know?
The POH.
Okay.
We already got that one.
The hydrogen ion concentration is equal to 10 to the negative pH power.
Okay, so we can go back and forth.
So if we want to find concentration, we just do 10 to the negative pH. And we're going to do examples of all of these. And then we have the hydroxide ion concentration can be calculated by doing 10 to the negative POH. Okay, so these things are going to stay up here.
Okay, and let's remember pH plus POH equals 14.
Yes.
We'll remember that. And KW, if you need that, is 1.00 times 10 to the negative 14.
Okay.
That's how you go back and forth between hydrogen ion and hydroxide ion.
So we will be doing that, plenty of that. So the first one, so what am I given in the first problem?
Okay, so we're given 1.67, the hydrogen ion concentration. And you may also see H3O plus the hydronium ion. It's the same thing if you see it.
So what is it?
Okay, 1.67 times 10 to the negative 10th. Okay, we need to calculate pH and POH.
So pH equals something and POH equals something. So those are the two things that I'm trying to find. I'm given hydrogen ion concentration, so I can use this one right here, right?
Well, if we're looking for pH, then yes. We'll just use the one that says pH first.
So what I'm going to do is I'm going to plug this in. My pH is going to be equal to negative log of 1.67 times 10 to the minus 10. Don't forget to use your E button. Okay, so I plug this in and I get my pH is equal to
9.78.
9.78. And if you forget to put this negative, your answer is going to be negative 9.78.
Yeah, and your pH can never be negative.
We don't want any negative numbers here. Okay, so if the pH is 9.78 and we know pH plus POH equals 14, well, just subtract 9.78 from 14.
And you'll get 4.22.
And that'll be 4.22 right there.
Okay, now you can always determine if it's an acid or a base easily from the pH, because remember it's a pH scale, 0 to 14. If you're going to use POH, it goes backwards and it gets a little bit confusing. So I have a pH above 7, so this is a base.
Okay, so I will say this right here is a base. All right, so successfully did the first one.
All right, let's do another.
So let me go ahead and erase this so I don't have to erase all of my formulas.
And all those formulas are on your formula chart as well.
Yeah, none of these things do you have to memorize, so please use your formula charts. Okay, so number 2, what am I given here?
Okay, hydroxide ion concentration of 7.19 times 10 to the negative 9.
Okay, and what am I trying to find?
POH and pH.
POH and pH, so just kind of like the last one here. All right. So I can find POH pretty easily by doing the negative log of the hydroxide ion concentration. So let's do that.
Yeah, you have to be very careful here just to make sure you know what you have. So if you do this negative log of the hydroxide ion concentration, that's POH, not pH. So just keep track of what you're given and what you're solving.
And that's, you have all these formulas here for you. So obviously we're able to do it a lot faster. But just make sure, you are putting the things in the right spot. So
okay, so that will be 8.14 for POH.
Okay.
And pH will be 5.86.
again, we just subtracted 8.14 from 14 because we know they equal 14. So since the pH is below 7,
It's an acid.
this is an acid, right? And remember, we always look at the pH to find out if it's an acid or a base. That's what we mean. You can look at the pOH, but we're used to looking at pH.
Right. Easier that way.
All right, now let's look at a couple of different ones where we are given the pH or the pOH, and we have to find the concentration of one of the ions. So number 3, what are we going to start with this time?
Let's start with a pH of 6.49.
pH equals 6.49.
So it's an acid. And we're looking for the hydrogen ion concentration
So I want to know the concentration of hydrogen ions.
and the pOH.
Well, pOH I can do first because that's pretty easy, right? Yeah. I just subtract 6.49 from 14.
So 7.51.
7.51. Okay, that's easy. Now, what we have to use here is like I have pH and I want H+. Now, I can't use this one because this one is used if you are calculating pH.
Right, we're already given
I'm not
pH.
calculating pH, I'm calculating hydrogen ion concentration. So let's use this one right here.
Okay.
So that H+ concentration is equal to 10 to the negative 6.49. Okay, so when you type this in your calculator, you're going to have to type in 10 caret negative 6.49. That's what it's going to look like. Okay. So once you do that, you're going to get your answer,
which is 3.24 times 10 to the negative 7.
Okay, so we've got our two answers. The pH, we already know this. The pH was below 7, so this is an acid. All right.
Okay, let's do one more.
One more, just for good measure. Man, I'm getting so good at writing and erasing things, you would not believe it.
I see it.
Look at that. Just like a pro. Okay.
Okay, pOH of 0.57.
Ooh, pOH of 0.57?
Yes.
Yee. Okay, and what am I trying to find?
We are trying to find the hydroxide ion concentration and the pH.
Okay, so what's the hydroxide ion concentration and what's the pH? Again, the pH, I should do that first. Super easy. Subtract 0.57 from 14, and I get 13.43.
So that makes this...
This is going to be a base because that 13.43 right there,
yep,
totally basic.
Of course, we have to end on a base.
Of course, we have to end on a base because we're dropping it.
After this, yeah.
After this. We're not done yet. Okay. Mr. is getting distracted.
All right. So, hydroxide ion concentration.
I want that.
The same way we did the hydrogen ion concentration in the previous problem.
Okay.
So, 10 to the negative, or 10 caret.
Nah.
What are you doing?
I can't write negative 0.57.
Okay.
So that would be 10 caret negative 0.57. Again, that's what it's going to look like in your calculator.
So.
And that gives you an answer
of 2.69 times 10 to the negative 1. So.
Okay. That's the definition of a dropped base.
Yeah, and we're done.
Okay. We are done. Thank you so much for joining us. Please, please, please remember to look at your formula charts.
Please.
All this stuff is here or there for you. It's here as well. But don't forget to use that, please.